So from this figure, I've explained how can we bring this back to this shape, and we have an extra forces F. And for these two F, and by action and reaction, this means the F here. Now, and this is which plot is this one? This one's AC. This one is AC, right? So we can. How about we have one rod AC, and this F is the tension in the rod AC. So can we simply write it as TAC? TAC. So for this one, then of course we can write this is TAC, and this is also TAC. So the logic goes like we have the two forces here, and by action and reaction, we have these two forces. And this one is member AC. This one is member AC. So this force is actually the tension of AC. So we simply write TAC here. Now, I hope you can get the idea. Now we go to the next one. We do the same for A. So I'm just saying this for this arrow, it means these two are action and reaction. So this one you can simply just clear it out. Okay. I just mean that for these two are action and reaction. So and the next one we want to do is now, and what let's have let's copy this to here. So from here we have TAC. We have a force pair TAC and TAC here. We do the same thing on AD. We do the same thing on AD. So we take this. We take AD away, and we take AD away, and we want to keep the same shape. How do we keep the same shape? So we simply put a force here and force here, and force here and force here. So how do we call this? This one is AD, right? This one is AD, so one is called TAD. TAD. So this one is TAD, and this one is TAD. So we remove this rod and we want to keep the same shape. So we put we say this has tension, so action and reaction. So we have these two forces here. Now we can see these two are now separate. What should we do here? Now we can see these two are separate, right? These two are divided into two sides. So we have now we have rigid body A, and now we have rigid body B, C, D. Now, because for each rigid body, that we can write the equilibrium equations, right? For the rigid body on the left, we have summation f x equal to 0 and summation f y equal to 0. And on the right, we have summation f x equal to 0, summation f y equal to 0, and summation m equal to 0. Now, because rigid body BCD can rotate, it can rotate, but rigid body A cannot rotate. We look at rigid body A. So you write it down first. So and your classmate has said it right that this is essentially 1 point. Okay, it's actually 1 point, point A. So for point A in equilibrium, we have summation fx equal to 0 and summation fy equal to 0. This is only 1 point. How many unknowns do we have here? How many unknowns do we have here on the left? On the left-hand side, on this rigid body, how many unknowns do we have? Ax and Ay unknown from step 1. So we have unknowns are TAC and TAD. So we have two unknowns. We have two equations. So we can determine TAC and TAD. Is that so we from here we can determine the forces in TAC and TAD by removing this rod AC and rod AD. Of course, we can repeat this again and again. We can do this again and again. We have we can do this again and again. We can take out CP and we can take out CP and we can take out DB and get all the. For example, if we take away CP and we take away CB, we have joint C. For example, here we have if we So if we have if we take away this is what this is AC, and this is CD, and we cut it here and we cut it here, and then we have cut it here, and we have this is CB, and we have point C here. So we can do the same for point C, and we will have TAC here, and TCD here, and TCB here. So we can determine. So we can determine TCB and TCB because we know TAC from the last one. Now, in terms of physics, that some members would some rods would have compression and some rods would have tension. Let me write them down. So members can have for the members that we can have in physics, we have compression or tension. So in physics, that some rods will have some members will have compression and some rods will have tension for the members. But in working the problems, in doing your exercises, in doing your homework, you assume all members have tension at the beginning, okay? At the beginning. You assume all members are under tension at the beginning. And if it is in afterwards that you do all the calculations, if you see the tension is larger than 0, that means it's in tension. If T is smaller than 0, then it means the member is in compression. So I will talk about the other points after the rest.